really happy to have Joe Justice here. For those of you that don't know what Team Wikispeed is, you'll find out all about it soon, but this is really awesome stuff. You're going to find out how to build a car using Agile development. You're going to find out how a group of volunteers does that and how they won one of the X prizes doing so. So Joe's got an awesome story to tell. Without any further ado, let's get to the awesome part of the show.
I'm Joe Justice. I'm a business process consultant, and right now I'm based out of Seattle, Washington. But I'm not here to talk to you about that. I'm here to talk to you about what I do after work and on weekends. I'm the team lead of Team Wikispeed. We built a fast, efficient, safe, modular vehicle, and the first running prototype was built in 3 months. How's that even possible when the cars around us seem to change so slowly? Here we see a mainstream hybrid sedan, and over a 6-year span, it gained an additional 2 miles per gallon in fuel efficiency. And you can see they went from 1 air duct in the front to 2 teeny little ones on the side and back to 1. And that's the extent of the visual differentiation across 6 years. Existing manufacturing changes slowly because the cost to make change is so high. This black metal thing in the bottom, some of you may know, it's called a stamped steel die. They can cost over $10 million a piece to make. This picture was taken at the Tesla Model S factory, and they're pressing in aluminum door skins for the Model S. If an engineer found a more ergonomic, safer, or lower cost door design tomorrow, the company would ask them not to make it yet until they'd first paid for the first door mold. And this is why cars are typically on a minor model cycle of 3 years when they make changes like the front air vents, and a major model cycle of 7 to 11 years. Porsche is on a 14-year major model cycle currently. So you could go buy a brand new Porsche 911. Parts of that they developed the 11 years prior to that. And you could buy the best of what the engineers thought you might want 25 years ago. And you'd be paying new price for it. This is common in manufacturing. It's the standard waterfall development cycle with long lead cycles up front, and then they try not to enter a new iteration because the cost is prohibitive. So new ideas are based on what the engineering team thought you might want 10 years ago. Agile, as everybody in this room is passionate about, does exactly the same cycle but repeats it on much faster iterations. So the product your customer receives is the best you thought they might want 7 days ago. In some cases, with continuous integration and continuous deployment, it's the best you thought the customer might want 2 hours ago. This is only possible if we're practicing object-oriented architecture. If we had a Ford F-150 in front of us, or a Hyundai Sonata, or a Toyota Prius, and we were all asked, let's figure out how to change the steering system, we'd need to change the steering rack, and then that would affect the steering column, and that would affect the steering wheel, and that would affect the angle of airbag deployment, so that would affect the airbag sensor strategy, which would affect the wiring harness, the microprocessors, and even the stamped steel floor of that car, which is that multi-million-dollar die. That's why making a change to something like a steering system is, on industry average, a 3-year change. In the Wikispeed car, the steering rack's a module. You can see in front the pedal plate that has all the control aspects of the car on one module. We're able to make a change to that system in 7 days. If we're going to iterate quickly on a system, first step, we have to figure out its object-oriented architecture. It's loosely coupled modules. Just like we've been doing in software, or trying to do and doing it better and better since the 80s. We found that when we apply the same practices to a physical problem or even a service, we're able to iterate quickly and use Agile, Lean, Kanban, XP, and Scrum. This all lets us iterate our car in hours instead of on a multi-year lead time development scale. We call this extreme manufacturing. This is to say thanks to the XP crew, Kent Beck and others, who figured out the light lift set of practices that let us turn development up to 11. And what we've done is looked at each of those practices and said, what's its analog in what we care about, in this case, in ultra-efficient transportation. And I'll talk to you a little bit about what we think we're discovering as we're going along in this practice now. We're lean in that we use less stuff. This is a picture of an Arduino Uno. It's a $24 circuit board we use to replace a $800 proprietary part we used to buy. Now that would be lean in the manufacturing sense, and that's not new to manufacturing. But we're also lean in the software sense of lean. It's an open source tool. That means when we have new people come and join the team to help us develop our electronics solution, we don't have to train them on our proprietary encrypted system. There's hundreds of thousands of people worldwide that already know how to write processing language, a derivative of C, on the Arduino. They're already up and running. So we've reduced lead time before they've even joined our team, and we're able to reach out to a much wider base. We use Agile to reduce the cost to make change. Here's me in front of one of our backlogs in one of our shops. And the Discovery Channel is filming us in this shop. And I'm taking a card that says, swap in V4 engine module, because we can switch our engine modules in about the time it takes to change a tire, and saying, take the Discovery Channel for a test drive. If a new technology came in tomorrow, a game-changing battery electric technology or a methanol type of technology, we would just move a set of sticky notes. We wouldn't have to launch a multi-year planning and investigation committee, which would be common in manufacturing. It allows us to be agile across our entire product portfolio. We use Scrum teams to have the fastest method of collaborative teams that we know of now. That's kind of romantic. Because we found collaborative teams are the fastest method that we know of so far to develop new product ideas and have functional prototypes of them quickly. We do all of our work in pairs because that allows us to eliminate most types of documentation and almost all training. When a new team member joins, they're put directly into making a customer part with an experienced pair. We also do pairs of experienced folks and pairs of 2 inexperienced folks, and it allows us to increase our velocity across the board. For more information on that, there are a set of white papers on pairing that help explain the statistical and mathematic advantages to velocity when you have 2 people work on just one task, which sounds counterintuitive, but the white papers are there. I'd encourage you to search.
Mary Bob and Nick.
Mary Bob and Nick, reaction.
Wow.
We found that team morale is a direct multiplier of velocity, not plus plus, not minus minus, but a multiplier. For that, we test the cars every sprint, and the team members hop in and drive them different places. Also, right behind Rob Beresford there is getting out is a whole shelf full of beer. We use our backlog as a value stream map. So we continually change the columns in our backlog in our Kanban board. We change the columns of our Kanban board, of our sprint planning board, dynamically to reflect the real-time flow of the work we're doing. That way it serves as a value stream map continuously. If a Lean Six Sigma black belt visited one of our shops, that would be fantastic, and we'd love to hear what they would say. And when they do, we take advantage of it. But we don't want to wait for that input, so we make sure our backlog models our current flow so we can identify any time spent not creatively solving problems. This is what the car looked like underneath our first on-road prototype. When we were campaigning for the Progressive Insurance Automotive X Prize, 136 teams entered from all over the world, businesses and universities, chasing for a $10 million prize. While most of them were still in their planning phase, figuring out what they're going to build, who's going to build it, what materials they're going to use, what facilities and machinery they might use, we made a backlog of tests and did the fastest, cheapest, simplest thing we could think of to pass each and every test, and we had on-road testing numbers while other teams were still figuring out how much it might cost when they get started. This is exactly the story Agile teams have been seeing in software teams since 2001 and even before Agile had a name.
Wikispeed SGT01 pulling away from a stop sign outside of Hillsdale, Michigan. Driver Brian Ford, passenger Joe Justice, and this is Rob Beresford. Holy cow, they're just gone, Johnson.
By getting to test the cars every sprint, even way before we're really done, way before the car has a cup holder, but when it meets the minimum road legal requirements, we're able to have a lot of fun. And we were able to prioritize things that we discovered. We found some of the things we were trying to increase the fuel efficiency, also help the car be really fast. So we kept those.
Yeah, baby. All right then.
What's your thoughts on driving the car? What's your reaction?
Very possibly the fastest car I've ever been in. Unbelievable. Unbelievable. Really just like a rocket, especially that second gear shift. It's like the front wheels come off the ground. I think I'm speechless. It's just amazingly fast.
Not bad for a car that was engineered to try to be efficient.
Yeah.
Yeah.
Blows the mind. There's no reason efficiency has to be boring. That much is clear. This car is a rocket.
By being public about our demos way before we thought we were done, I mean, the car looked like that, we attracted investors. And they stayed on because they had updated demos every sprint. We didn't have any additional conversation with investors other than making our demos public. So we were able to eliminate all that other overhead, and we just used the 3 ceremonies of Scrum, or 4, depending on how you count them. We sold a car when it looked like that, way before we thought anybody would even consider it. But folks being able to interact with it, we got to discover what the early adopters actually wanted and prioritize the backlog accordingly. When we entered the X Prize, when we campaigned at Michigan International Speedway, the car was aesthetically challenged. We had a NACA airfoil on the front, NACA being the predecessor to NASA, and you can't see it in this picture, but there's the same slope, another NACA airfoil on the tail, giving us the aerodynamic profile we cared about. And when the team started, it was just me. It was in my garage in Denver, Colorado. And I blogged about everything that was going well and not going well, essentially my retrospectives, because I was an Agile software developer. I was not an automotive engineer, but I couldn't sleep at night if I hadn't done something to try to do ultra-efficient transportation. I just became really excited about it. And people started visiting my garage, responding to the blog posts to see this thing they'd seen on the internet. And some of them stayed to help, which I'd never planned on. But it was amazing. And by the time we were a finalist in the X Prize, we had 44 volunteer team members, all with day jobs, working after work nights and weekends because they thought it was awesome, in 4 different countries. They'd mail in parts and we'd get a package from Ireland or a pallet from South Africa, and we'd test them together in my garage and in other garages around the world. And we didn't win the X Prize. We tied for 10th place. We came in ahead of over 100 other cars, including some names you might know, like Tesla and MIT and Tata Motors in India. We didn't get the $10 million prize, but by getting 10th place, tying for 10th place in the mainstream class, we got several $100,000 of road legalization consulting. So we said, let's try to make these cars something people might want to drive to work every day. Very few people will want to drive that to work every day, even if it's ultra efficient. So we're in the red-green refactor loop, as extreme programming calls it. We started with our list of tests, the offset frontal impact test, side impact test, roof crash test, the EPA city test, the EPA highway test, ergonomic tests for the drivers. As a driver, I can drive to work with 10 cubic feet of trunk space that's weather tight. Those type of user stories. We started with this list and they're all in the red column. And now we've moved them all to the green column, but it's the simplest version that might possibly work, and that's what you see. So now it's time to refactor. Let's get some of those tests back to red so we can have a V2 or a V5. And we came with this car. 7 of the 8 modules are the same. We didn't have to change them yet. But we put this on and we unveiled it at the largest auto show in the world. I was terrified. They decided to put us between Ford and Chevrolet and around the corner from GM. I thought the companies would be angry. Who's this company claiming to get 109 miles combined in EPA testing? That's what I thought we'd hear. We got to meet execs from every automotive manufacturer, and every single one shook our hands and said, "Good job, go get them." I've had a lot of time to think about why that might be. My best thought is a lot of them wish they could do quick prototype projects, but they've got this very large company with a waterfall system, and it's the antithesis of agility in their project portfolio. That's my best guess, is they wish they could be like that. And that's why some of them are our consulting clients now, and I'll talk to you about that in a moment. Then we got this rendering and said, yeah, we'd like to build that. I'll talk about that in a moment. Team Wikispeed is now in 20 countries, and we have more than 175 regular folks. More than 500 people have signed our volunteer form, saying that if they drop the car on their foot, they don't own the company, but we will take them to the hospital. And that they can even keep their own IP if they want it, but Team Wikispeed gets to use it too. And that's it. That's all we ask. And more than 500 people have opted into that. And this creates a problem that distributed software teams see and already know how to deal with. That's continuous integration. So if you have shops in 20 countries all producing car parts and CAD and designs, how do you then have any type of coherent product at the end? Well, what we do is we have a single centralized store of our CAD files, and we have some automated gated check-in. In the automotive world and in most types of engineering, there's the practice of finite element analysis, where they take your 3D model and they apply virtual torsion and they see how strong it is. And they apply simulated crash tests to it and see how it behaves. That's all simulated. We run those on the CAD as they're checked in. And then finite element analysis, and then computational fluid dynamics, where how the airflow flows around, how the electricity propagates, and how heat dissipates. This lets us measure with some level of objectivity if the CAD passes our build check-in, just like software teams do. Now this is very new outside software. So I hope what some folks in this room are starting to realize is that you're ambassadors to every other business on the planet now. Because you guys understand these practices, do them already, and most of the world stands to benefit a massive amount for them. Remember when you first adopted Agile practices and your velocity went up 2x? Say you were using Scrum and you had a dedicated Scrum Master role, so they measured velocity, so you got to compare from sprint to sprint. And say you used retrospective discipline, so you made just one change every sprint, so you got to apply scientific method and see what affected your velocity. So you tuned your team and hit 2x velocity. If you're industry average, that took you about 3 months. If you kept doing it, maybe some of the folks in this room were on ultra high performing teams that hit 10x their velocity. Well, if the current Porsche life cycle is 14 years between major model changes, what if it was 1.4 years? What would that do? What would that do for vaccines? What would that do for cancer research? What would that do for medical equipment? What would that do for social good initiatives? Let's talk a little bit about that. But in manufacturing, we also then have the issue of continuous deployment. If you even have a coherent design, how do you then get all manufacturing lines to produce the same thing? That's maybe one of the more clever things Team Wikispeed has come up with. We're not in a high volume scenario. We've made more than 100 iterations of our prototype cars, and we've sold 5, which I'm very happy to say, and none of them are really what I would consider done yet. They're prototypes. They still don't have cup holders. The fact that folks bought 5 already is totally cool that they're interested in that. But some of our clients are in volume scenarios. So we've helped them develop a set of practices just by looking at how software teams do continuous deployment to help deploy to manufacturing lines. If Chrysler wants to make a new type of transmission, they go out shopping for land, work with the local government to have the government pay them to build there, at least build roads and infrastructure in, then start building the plant, then start hiring and training staff to make a new model transmission. It costs several $100 million. If you deploy a new set of designs to your manufacturing line every week, that's completely incompatible with the current model. This is where continuous deployment, as you guys already know it, gets translated. And now we do have dynamic factory floors where they're able to deploy same day, fully new designs. And this is brand new tech. And again, you guys are the ambassadors of this to every other industry now. And then the reality is we have external dependencies via third-party parts. How do you work with them if they're still on the waterfall model and they say, yes, I can get you your first prototype of that in 18 months and we can be ready for volume in just 2.5 years. Thanks so much. We use the wrapper pattern. We aren't able to speed them all up until they choose to explore agility, just like software teams know now. But it's like having a legacy COM object and wrapping it so that you can swap it for another updated assembly or another vendored part or another COM object or a .NET assembly or a gem. And you always work with the same interface. So we wrap third-party parts in aluminum structures with a known bolt pattern, so we can swap them back and forth within 1-week sprints. John Deere had a set of execs see an article about us in a magazine on an airplane. They flew a set of managers out to one of our Wikispeed shops and says, yeah, this seems like the real deal, which blew us away. We were in a garage. And now we're part of their Agile transformation strategy. Boeing took us on a tour of their largest enclosed space in the world, where they manufacture the 787, 777, the 767, and also some of their military stuff. It's so big, they tell us, that they've had clouds form inside the building and it's rained inside the building. We then invited them over to one of our shops, which was smaller. And they had 27 executives show up and they hosted a white tablecloth dinner in our garage. One of their execs is a double PhD in computational fluid dynamics and finite element analysis. Two complementary but very divergent disciplines. And he said, the processes and tools we use at Boeing are more sophisticated, but you're light years beyond us in terms of culture. I didn't expect that at all. I thought they were going to say, the fact that you guys have daily stand-up meetings to share what's going well and to have daily retrospectives in the form of your stand-up meeting is innovative. The fact that you have weekly retrospectives and potentially shippable product every week, that's game-changing. But no, they said it's that we had a mindset to want to do those things. That our culture made us desire those things was novel. And that hit me like a ton of bricks. This is Tecan in Switzerland. They make automated and semi-automated lab testing equipment. We're now part of their Agile transformation strategy. They already had Agile practices in their software teams. They had no idea how to scale that to the rest of their company, especially into their manufactured products. Folks like you can help make that happen at all the companies around the world you might want to help speed up. Then Lockheed Martin gave us a call. They'd seen us present in Texas at Agile 2012. And they're one of the largest military manufacturers and designers on the planet for the United States and other countries. And they said, as part of our Agile adoption strategy, let's have you guys train up our software teams by having them build the modular car so they have hands-on understanding of object-oriented architecture and fast-paced sprints and how a Scrum Master will help them work and cross-functional teams. So they started with an aluminum frame and a roll of carbon fiber and snacks and a set of tools and a bunch of other parts. We had suspension modules prefabricated, and we weren't allowed to bring an engine into the building, which I thought was hilarious, because these are people that build rocket boosters and they're not trusted with gasoline. And we gave them a backlog and no instructions. We said, here's your product owner, here's your Scrum Master. They're not allowed to tell you how to do your work explicitly because you'll go slower statistically if they do. But what they will say is, here's a backlog. There's no pictures, there's no videos, there's no instruction manual, go. And they got to here, and they got to here, and they ultimately got to here in 11 40-minute sprints. If we'd had an engine module, they would have been able to drive the car out of there. Although they had to take it apart because the building we were inside didn't have doors that opened that wide. Then Tate Radio is in Christchurch, New Zealand. Their Agile adoption was fueled by their employees. They said, we want to be the #1 place to work voted by our employees in all of New Zealand. So let's be Agile, because that has the principle of building our teams around motivated individuals and giving them the resources and trusting them to get it done. We think that will help boost employee morale. This is their P25 base station. It takes a radio signal in, it decrypts it if it has to, cleans and boosts the signal, re-encrypts it if it has to, and broadcasts it back out. It's used by the military, ambulatory services, law enforcement, fire protection. And they said, let's make a new version of this and let's do it like Team Wikispeed does. And we said, cool, let's do Agile and hardware. And they gave us a set of hardware engineers with soldering irons and with circuit board simulation software. And we said, doesn't software also run in here? And they said, yes. And we said, then we'll need everybody required to go from an idea to it in the customer's hands. And they said, really? That's a lot of people. And we said, yes, we need all of them in one room. And they sent us 3 different types of software developers, 2 other types of hardware engineers, marketing, customer relations, shipping, quality assurance, test, and even the packaging folks. The fastest they'd ever made a new revision to one of their hardware products before was 3 months. Typically, it takes them multiple years. We had them create a backlog of sticky notes of everything they thought was required to make this new version. They'd been making radios for 60 years in this company. In 1 week, we had almost double the number of sticky notes created. Just like you see on Agile teams all the time, discovered work happens in every business I come into, regardless of how long they've been doing it. The team launched on Monday, and they handed a working prototype to a proxy customer on Friday. It was the fastest that company had ever had a hardware turnaround, and this was an integrated hardware and software turnaround with updates to the application used to manage that hardware as well. This is how Agile might scale. When we look at reports of Agile teams and their successes, or we read books on Agile, most of them are about software delivery teams. When Agile was coined as a term in 2001, most of the companies that took it on were software delivery teams. Not all. Agile has always been broader than that, but that's the majority. In 2004, I bumped into a term, Agile 2.0. It was referring to companies who had had fantastic success in their software delivery teams and said, but what would this look like in design, in accounting, in legal, in our executive tier? And they said, let's try it everywhere. And some of them had phenomenal successes. And they said, this is Agile 2.0. This is Agile for the whole business, every aspect of it. We have Scrum teams and human resources pulling from a human resources backlog. Agile 3.0, the first time I ever read about that was 2008. It was the science of morale as a multiplier for velocity. If morale has a statistical correlation with how fast the team delivers, and that's been proven, what's the science behind it? So it's not just we're lucky enough to have a team that really gets along, but we're able to help foster that in a repeatable way. That's championed, I'd like to say, by Nikki Hare at the University of Auckland in New Zealand. She's the psychology chair there, and there's fantastic numbers and data under that, and I'm a huge fan. This is a team doing Agile 2.0 all at once. It's a relatively small company. There's 74 employees. And what each group is doing is they're doing a retrospective of the way they work now versus the 12 Agile principles. So right in front of us happens to be human resources. And they're saying for this Agile principle, what are the things that make this principle come true? And what are the things we're doing now that slow down or get in the way of this principle? After that, they each made backlogs. The entire company did it together in 2 days in one room. They rented a lodge together. Here's the same thing happening, but with more than 20 different nonprofit companies in the state of Washington. Right here, I'm helping a nonprofit representative groom their backlog to help make the world a better place. Some of these are software applications. Some of these have nothing to do with software, like urban food kitchens and having healthier menu items in grade schools, high schools, and middle schools. Here's a set of more than 20 companies, and in this case, mostly just their owners and their C-levels showed up. In Rome, Italy, Simon Cicero is front and center. He's doing translation for me, and he's also a brilliant thinker, and he's adding quite a bit to the conversation. And these companies are all undergoing Agile adoptions right now. The majority of them are not software companies. This requires an enormous amount of enthusiasm because it's hard work. Changing the way you work at a company culture level is absolutely the most uncomfortable thing a company at a time could try to do other than make themselves go bankrupt. I give jumping high fives all the time and use words like awesome all the time because I like to. And because you have to if you're doing hard stuff like enterprise agile adoption. This is really difficult stuff, and if you're not giving jumping high fives, it's not going to work, and it's especially not going to work quickly. For more information on Agile, Lean, Scrum, Kanban, XP, and this extreme manufacturing thing I'm talking to you about, the Solutions IQ blog is a pretty good source. That's my current day job. Wikispeed is my nights and weekends project, and during the day I go out and help businesses do this, and that's where a lot of that data is stashed. I'd encourage you to take a look there. I'd like to welcome up Agile Bob Hartman, to talk a little bit more about morale as a multiplier for velocity and high-performing teams.
Thanks, Joe. You guys are an amazing crowd, and I think we can all agree, Joe has an amazing story, right? I mean, this is unbelievable. I'm honored to be up here because as some of you have been through my classes, seen me talk before, I love to talk about the human elements of software development. I believe we spend so much time worrying about how we do it, we forget that we're people at the core of doing that. And we end up making huge mistakes around people. We end up having people do things that are silly. For example, oh, you have 10 times the amount of work you need to do, but you have to do it in this period of time. So the person says, thank you, can I do that again next week? Right? I mean, we do all kinds of stuff like that. Scope creep is okay. Oh, the project date doesn't move, let's add more scope. There are human aspects to this that are just enormous. And we have to remember the human element is really, really important. As Joe said, morale is not just a little bit. It's a multiplier for velocity. You want your velocity to go up? Have your people have higher morale. There's a study that was done. They studied IT executives and they asked about morale. 66% said low morale. Morale is an issue in their companies. 34% said it's not an issue. I find this statistic really interesting. I do not know if there's a correlation here, but it seems like there should be. The Standish Group says about 32% of projects finish on time. I'm thinking those numbers might correlate just a little bit, right? That's the type of stuff we're talking about. There's another study out. It was actually called a meta study by the Gallup Group. They studied a bunch of different types of studies around employee morale. Their findings were staggering. Now, this is not just Agile companies. It's companies of all types. High morale companies, 16% higher profit. 18% higher productivity, 12% higher customer satisfaction. And then when you want to figure out how velocity is multiplied by morale, think about this one, 60% higher quality. If your quality went up by 60%, how many fewer times would you spin at the end of projects? How much time would that save? How much higher would your throughput go? This is a game that we think we're playing where we can't win. The bottom line is we can win. We have to pay attention to how. Some of the things you can do. Help people understand it's not just what they do, it's how they feel about it. Joe several times has mentioned social things, causes. Well, you know, you all work for a company. What if the company's cause was something you believed in? Wouldn't you have higher morale? Wouldn't that make you want to work a little better and a little harder? Part of the job we have as Agilists is to understand the work we do affects the world. I did a class at Buckley Air Force Base. And the people in the class were people who work on the Army requisition system. I don't know about you, but that sounds like really boring software, right? But that was their job. But they couldn't see how that really impacted the world. Well, what they didn't tell me at the time, and they told me during this discussion, was that requisition system is used by teams in Iraq and Afghanistan. Well, they couldn't see how it affected the world, but I could sure see how if their system didn't work, we'd have an awful lot of people in harm's way. Right? When they started looking at the real impact of what they were doing, it completely changed their mood about what they were doing. Can you understand how what you're doing changes the world, and can that change your velocity? I think it can. There's another thing we can do to really help people. In the waterfall mentality, we have a problem saying a word that we should have no problem saying. Too many times, we can't say,
"For the last time, no."
We have to use the no button a little more, right? No to scope creep that doesn't make sense. No to these things that don't help. Joe has to make lots of tough choices with Wikispeed. That's a great idea, but you know what? It's not one of our sticky notes yet. Right? Put the sticky note where it belongs, in the icebox or something else for the future. It's not all about doing cool stuff every single day. It's about making a great product now and a better one next week and a better one next week. Morale is all about a buildup. It's based on culture. Like Joe, I've done a lot of studying on culture. And one of the things I found out about culture is it's a result of all of your previous results. The company culture didn't start out where it is today. It got built up over time by what was happening. Change what's happening. Start being successful. Start delivering on time. Start doing the right things. Start continuous integration, continuous deployment. All of these things we say we do, but you know what? If you raise your hands honestly, we don't really do all those things all the time. They make a huge difference. They put you in control again, and they empower you to make decisions, including the decision to say
No!
Right? Sometimes you just have to say no. Help your teams learn how to say no appropriately. And by the way, no shouldn't be changed to no problem, we can do that. Right? I had a team in California that the VP actually wanted me to do a spelling test where people had to spell one word, no, because in their emails it kept coming out Y-E-S. Right? So make sure that we're building morale by doing the right things, protecting your teams, doing the right stuff, and you can be awesome. I love that word, awesome. That's what we're all about. That's what the type of stuff Joe's going to talk about, and he's got a lot more to talk about with extreme manufacturing, so thank you.
So how do we actually make a potentially shippable product in hardware in 1 week? We're on 1 week sprints, and that's hard in software. How do we do it when we have manufacturing? Well, I'd like to show you 2 sprints. This is an actual safety iteration. First, we choose the test we're going to try to meet. In this case, it's the National Highway Transportation Safety Authority side impact test. We then simulate that test. Here's our chassis being struck by a model of the deformable barrier that they smack into it at 35 miles an hour with a 5,500 pound weight behind it. Then we perform that test in physical reality to see how close our simulation was. That test costs us $10,000 every time we run it, plus the cost of the car, plus the cost to deliver the car there, and then the cost to recycle what's left. We can't afford to run that test every 7 days, but I just told you we make new tested iterations every 7 days. Our simulations are so accurate now that they're accepted by the government in place of physical testing. What we do is we still conduct physical testing to make sure our simulations are still indicative of reality, or they highly correlate. Then we iterate on the design. Here's an update to that side crush structure made by a father and son volunteer team. The same day the video of that impact test was sent out to the team. They said, we can do even better. They came over to the shop, they cut some lower grade aluminum which has a lower yield strength and lower fail strength than the yield strength of the chassis. So it'll turn into a pancake before it starts to flex the frame or the chassis. And they knew that because we had posted on the walls an information radiator, yield and fail strengths of the types of materials we use in the shop. And that had an even higher crash rating. Now I'd like to talk about how we make the vehicle a little more pretty, or we try to, every single week. Here's an aesthetics iteration. We start with CAD, or a three-dimensional drawing. Here's one of them developed by Rob Moorbacher in Germantown, Maryland. When he sent this to the team, none of us had ever met him in person. He sent us a link to a SkyDrive box showing, here's a CAD file I drew that I think will fit over the car. We tested that it fit the car, fell in love with it, and we used a CNC machine, a machine that's controlled by a computer, to cut it out in foam in one day. So one day later, we have a life-size foam car to walk around. Then we lay it up in structural carbon fiber over the top like an eggshell in one day. Now we have a structural carbon fiber car that's full size. And then we took that to the largest auto show in the world, and again, we were absolutely panicked. And luckily for us, the car was beautiful. So that is one aesthetics iteration, but it's not actually done. The Discovery Channel came to film us, and we asked them for permission to use that video in a crowdfunding campaign. And we launched that crowdfunding campaign from what iteration to finance the next. The idea here being, we don't want to be funded through the end of the backlog because it changes every sprint as we learn more. We don't want to be funded to milestones because then some funder has a perception that that's what they bought and we've lost a level of agility. What we aim for is to make sure we've done something so awesome this sprint that someone will crowdfund our next sprint, and it's worked every time so far. Here's car number one. It was just recently filmed by Bradley Hasmeyer and Translogic for the Speed Channel, and there he is leaning up against car number one. And that's our test mule. So we take it apart and put it back together every sprint to test new versions. Then car number two is the car we unveiled at the auto show. That's the car that was crash tested. It survived, so we crash tested it again at higher speeds. So we don't have car number two anymore. Car number three is in Germantown, Maryland. Rob Moorbacher now has his own car, and that's where he makes, that's where he test fits. It's now his integration test bed. So as he pulls carbon fiber cars out of the molds he makes every week, he does integration testing there. And here you can see LED headlights being tested. Car number four was bought by a mountain climber. And he says, if I'm going up to these pristine alpine areas, I want to make sure that I'm not emitting a large amount of pollution, because sometimes he'll have to drive 7 hours to get to where he mountain climbs. And what he loves about them is they're pristine. So he said he wants to go there in an ultra-efficient vehicle, and we're building his vehicle now. Car number five is also not done. 4 and 5 you can see are in progress. Car number five was also purchased by a military veteran. And he wants it to be his eco-friendly supercar, his hypercar to drive around and grab attention, but grab attention to show that he's trying to make the environment cleaner. Not a Lamborghini, not a Ferrari, but something with ultra-low environmental impact. Car number six goes into the Future of Flight Innovation Center. It's a museum at Boeing's Payne Field next to the cockpit of the Airbus A380 and the Trent Rolls-Royce jet engine. They have an exhibit for the Wikispeed 100 mile per gallon car. That gets delivered this Saturday. That car is having its decals put on. This is the state of that car from last night, and as a jumping high five to the folks from Agile 42, they're a sponsor of the car. They send us $100 every month, which to us is huge because we're this really frugal company. So over the engine, there's an Agile 42 logo. That's from last night. It's getting applied. This morning, I should have a picture of it on that car that goes into the Future of Flight Innovation Center, where more than 200,000 people will interact with it every year. Thank you, Agile 42. This is my car. It's not done yet. That's the CAD. We have part of the chassis. It's being fabbed now. Car number 1 was my car, but it's always being taken apart and put back together, and I almost never get to drive it. So I said, all right, I'll get another one, and I paid cash as a third party would, and my car is now under development, and I got to pick exactly what it looked like because the car's modular, right? It could be a big carbon fiber rocking horse on the top, whatever you want. And that's exactly what I wanted. Car number 8 was bought by an engineering team. It's now required for their engineering majors to graduate that they've iterated and moved forward the design of the Wikispeed car, module by module. Car number 9, that's about all there is of it right now. It's being produced right now. That was also purchased by an entrepreneur who wants to show that eco-friendly supercars are here now. And now they're not all supercars. They're designed to be ultra-efficient commuter cars. But the first 10 cars need to appeal to early adopters. So we absolutely ramp up the sporty, just like Tesla did. They started with a really sporty vehicle, and now it's a little more mainstream and a little more mainstream. And that seems to be an effective strategy. We're trying it too with our first 10 cars. The plan, though, is to make ultra-efficient commuter cars that about 20% or more of the population would seriously consider driving on their way into work. Because if we sold 100 cars for $100,000, that might be a successful startup, but it wouldn't help the environment very much. It wouldn't make that much of a dent. We need to be thinking in much larger numbers and at much lower cost. The highest volume of vehicles in the United States are sold at an average transaction price of $17,000. That's our target. Our supercars are sold now. I still don't think they're done. They still don't have cup holders, but you can see we have some out in the wild and some are bought. They're $25,000. That's ridiculously cheap for a new automotive company. Typically, it's over $100,000 to justify the costs of tooling. But as an Agile company, as a lean company, as an XP, or in our case, XM company, we don't need that. We're able to sell them at $25K, and we use that to organically fund the mainstream car, which we're working on now. We call it the C3, the comfy commuter car. This is a picture of a polar bear giving a high five to a robot in front of a supernova. I've gotten to talk to you guys about ultra-efficient transportation. That's cool. Team Wikispeed isn't actually about cars. That's the most visible thing we're doing. It's the most popular thing we're doing, and a lot of people resonate with cars, and almost everybody knows what a car is, so it makes a great example. But that's not actually what Team Wikispeed's all about. Our mission statement is rapidly solving problems for social good. When we looked at how quickly we were able to develop a working prototype of our car, 3 months, and we compared it to industry average, we were 10,000% faster to go from a prototype mule to a prototype mule. We did that in a space where we also at the same time solved a problem that all existing manufacturers had previously said was unsolvable. 100 miles per gallon, 4 seats for 4 adults, road legal safety requirements, ultra low emissions, at least 200 miles range. So we solved this potentially unsolvable problem, and we weren't the only ones who did it, but we were one of them who did. Like I said, we didn't win, we tied for 10th. And we did it in record time. And we said, let's do that with things that are really worth doing in addition to ultra-efficient transportation. The first Agile project I worked on outside of software was helping deploy the polio vaccine to congested urban areas of India where it was needed the most. The Team Wikispeed backlog is full of items like rotavirus vaccine distribution, low-cost medical centers. We're working on now the Wikispeed microhouse. The idea is to help eradicate involuntary homelessness. I think it's pretty cool if people want to go live in the woods for a while. I hope they can still do that forever and that there's still lots of woods for them to go live in if that's what they want to do. But if folks want a clean bedroom, clean bathroom, and a lockable front door, we'd like that to be available for everybody. That's a tough problem to solve, but it would be kind of awesome. And we have a prototype, and its user statements are, as a user, I can have a clean bedroom, clean bathroom, and lockable front door for less than $100. It's not done. We haven't solved it, but we have a prototype, and we have some work towards it that's meaningful. We're not that far off, we think. So that's in our backlog now. I'd encourage everybody in this room to say, well, Agile helps me solve things at lower cost, have usable results early, and have happier teams. Maybe I should apply that to things that are really worth doing. If I got to ask everybody in this room just one favor, I would say, join Team Wikispeed. Email us at info@wikispeed.com and spend about 2 hours a week or more if you've got it with us, rapidly solving problems for social good. You can do it from your home, or you can come into one of our shops, or you can do it anywhere you have a laptop. We have plenty of virtual tasks. But you don't have to join Team Wikispeed to make the world awesome. You can use Agile for social good projects anywhere with any group. If I got to ask everybody in this room just one favor, it would be spend 2 hours in the next week rapidly solving problems for social good, and use Agile so that you'll get it done fast and cheaply, and there'll be a usable version in maybe 1 month instead of 3 years or never. And if everyone in this room did it, it would be so awesome. It would be like a polar bear giving a high five to a robot in front of a supernova. Thank you very much.
Lives. All right.
I assume we don't have time for Q&A, so please email info@wikispeed.com with any question. I answer it, but so does the whole team. So you can say things like, do you guys really, or Joe said you did, do you? And you'll get answers from everybody.
Awesome. So that was awesome. Another round of applause real quickly for Joe Justice.